Hello, the following lecture will establish the fundamentals for understanding the concepts of gas laws. And one of the first principles of gas laws is the concept of pressure. Because gases can be compressed, they can exert pressure on themselves or on the atmosphere or on a container. And there's two ways we think about pressure. If you were in physics, we could give a formula for it. So pressure is measured by how much force is being exerted divided by the area on which it is being exerted. So imagine a balloon and you push with the same amount of force if you have your hand. So this guy's hand pushes on the balloon. Even if you push pretty hard, it's kind of difficult to pop a balloon with just your hand. However, if you have a balloon, the same size balloon, and you bring a pin close to the balloon, and you push with the same amount of force that you pushed with your hand. So if the forces are the same, but the area that is pushing on the balloon is so much smaller, that really increases the pressure. So by decreasing the area of the pressure by using a pin, you really increase the amount of pressure being exerted on the balloon, and that's what allows a pin to pop a balloon much easier than pushing on it with your hand. So if you were in physics, this is the equation, the mathematical equation for pressure. When we think about chemistry, we're talking about all of the particles inside a container. And so particles of a gas are moving very quickly. And so the way to think about pressure in chemistry is the number of collisions between particles within a container and on the edges of the container. So you have collisions happening between these two particles. Eventually this particle could run into this one. But then also this particle runs into the sides of the container. So pressure is a measure both of the collisions between particles and of the collisions between the particle and the container. So as we think about pressure being a measure of the number of collisions happening for gases, there's lots of different ways to measure pressure. So if you were at sea level, we would measure the weight of the atmosphere as one atmosphere. So literally the atmosphere is a unit. 1 ATM stands for 1 atmosphere. That's equal to a couple other different units. So there is this unit called the torr, which is literally the same as 760 millimeters of mercury. So if you're at sea level, the weight of the atmosphere would be 700 millimeters of mercury. That means it could push up mercury 760 millimeters. I'll show you a diagram of that in a second. That's also equal to these units called kilopascals. So 760 millimeters of millimeters of mercury is equal to 101.3 kilopascals, which if you wanted that just in regular pascals, that's 1.013 times 10 to the 5th pascals. Okay, so all of these units are equal. So if you needed to convert atmospheres into kPAs, let's say you have 0.95 ATMs. We know that 1 atmosphere, and this is exactly 1, so for the purposes of significant figures, remember this is a conversion factor. Don't limit by 1. So if you have 1 atmosphere, that is going to equal 101.3 kPAs. So this is an example of a type of conversion that you would have to do. And so if you did this conversion, you would end up with a measurement of 96.2. And because there are only two significant figures, you have 96 kilopascals. All right, so pressure is one of the qualities for gas laws. And since there are so many different ways to measure pressure, all of these different units have been established, you need to be able to convert between all of them. All right, another concept that is kind of important in for gas laws is the idea of temperature. And temperature seems like something that everybody should understand, but really temperature is a measure, well, I should just say, it's an average Okay, so temperature is related to the average kinetic energy of the particles. So consider, for example, solids, liquids, and gases. If you have a particle that is stationary, not moving, well, these are moving very slightly. They're like vibrating. Okay, so solids are structured and ordered, but their particles are not moving very fast at all. Compared to a liquid whose particles are moving, but just like sliding past each other, they can rearrange and form the shape of whatever container it's in. So there is some movement in the liquids. But gases are definitely moving the fastest. They have to move the fastest to overcome the attractions. All right, so the faster the particles are moving, the greater their temperature. That's the most important idea for gas laws, considering the movement of the particles as a depiction of the temperature. And we have a temperature conversion also that's kind of important. So most of the measurements you make in a lab will be measured in Celsius, degrees Celsius. Okay? So the SI unit is degrees Celsius. However, absolute temperature is measured in Kelvin. Okay? And the relationship between absolute temperature and the SI measurement of temperature is that temperature measured in Kelvin is equal to whatever your temperature is measured in degrees Celsius, we're going to add 273.15. So this is one of the only conversions that we do in this class that is an addition problem. Absolute temperature is important because just as we were talking about temperature being related to the motion of the particles, using absolute temperature allows, when the temperature is zero, there is zero movement. So we've never achieved that temperature, but theoretically, if you were able to stop the motion of all of the particles, the temperature that matter would be at then is 0 Kelvin. Okay, so the concepts of pressure and temperature are both pretty important, and they lead to this conversation of mathematical relationships. So there are two relationships that we particularly care about in this class for gas laws. So a direct relationship looks like the relationship of a line. So this looks like a linear relationship. So in a direct relationship, it looks like a line, except that it goes directly through the origin. So in this case, B is 0. So in a direct relationship, you don't even include the B term. So the formula for a direct relationship is whatever variable is on the y-axis is equal to the slope times whatever variable is on the x-axis. So the other relationship we care about is an inverse. And in an inverse relationship, as one variable increases, the other decreases. So whatever the value of the slope is divided by the x, and m could be any number, it could be 1 or depending on how sharply this changes, that's what x is going to represent, or m is going to represent. But overall, in an inverse relationship, as the value of the x-axis increases, the value on the y-axis decreases. And vice versa is true. As y increases, the x value has to decrease. Okay, so in these two mathematical relationships, we will see how the gas laws are related. So each of these is important and relates specifically to one of the gas laws. So that's it for the first gas laws lecture. If you have any questions, you can email your teacher. Good luck.